Hello, students. Today, we'll be dealing with chapter 1.2, how we can improve precision in measurements. Let's get started. Instruments with greater precision of measurement. Precision is the closeness of two or more measurements to each other. It is also the degree to which repeated measurements under the same conditions show the same results. Precision and accuracy work hand in hand. Accuracy, however, has to do with the degree of closeness of measurement with its true value. Measurements that are both precise and accurate are repeatable and close to exact values. We are to drag the following words into the correct boxes to have this activity done. A meter rule is a simple measuring instrument. Some other instruments are designed to give better precision in measurement. Such instruments are micrometer screw gauge, multimeter, and the vernier caliper. So let's check. That is correct. Let's move on. Let's deal with vernier caliper. As you can see, this is a typical diagram of a vernier caliper. Looking at the features of the vernier caliper, we can see the inside jaws, the outside jaws, the object being placed, looking like a cylindrical object. We can see the two main scales, the two main scales. We have the main scale itself and the vernier scale, together with the strip associated with the vernier caliper. So, we need to drag the following words into the correct boxes to be able to solve this activity. The vernier caliper has two main scales. The main scale and the vernier scale. The combination of these two scales give the measurement of the distance between the inner faces of the jaw of the vernier caliper. Before using the vernier caliper, zero error needs to be checked. Let's see. So, check. Correct. Now, in the vernier caliper that is illustrated above, rather, what is the total reading on the scale? Now, let's do it one, then the other. If you should look at this reading closely, the total reading that will be observed, the total reading is equivalent to the main scale reading plus the number of divisions multiplied by least count on the vernier caliper. Now, main scale reading Looking at it closely from 10 here, the one at the top is the main scale reading. Now let's take it, this is 11, 12. So here now we have 12.5. So you have 12.5 millimeter. Then number of divisions is equal to, looking at the ones below, so you get to where the reading on size. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, where they concise, where they meet, rather, that's 17. Now, multiply 17 by the least count. One of such count is 0.02. And that gives 17 times 2 over what? Over 100. And that is 34 over 100. That gives us 0.34 millimeter. So add 12.5 to 0.34, all in millimeter. That now gives 12.84 millimeters. So with that, let's check whether we have the answer. Yeah, so we can check now. That is correct. Moving on, let's go to micrometer screw gauge. Looking at this diagram, the micrometer screw gauge has different parts. We have the anvil, the spindle, the sleeve from where you take your measurement, and also the thimble and the ratchet knob. We also have the frame. We have to drag the following words into the correct boxes to have an activity done for the micrometer screw gauge. Micrometer screw gauge, like the vernier caliper, has two scales. Now, the main scale, which is located on the, where is it located? Look closely, is located on the shaft, and the fractional scale, which is located on the rotating barrel, that is on the thimble. The fractional scale has 50 divisions, so that one complete stone represents 0.5 millimeters. So we can check, that's correct. Now, let's have some facts about the micrometer screw gauge. The method used in measuring for the micrometer screw gauge is as follows. You have to turn the barrel until the jaws just tighten on the object. Read the main scale to the nearest 0.5 millimeters. Read additional fraction of millimeter from the fractional scale. That is how to do reading on the micrometer screw gauge. Now, looking at this diagram, the diagram shows part of a micrometer screw gauge. What is the smallest reading that can be achieved using this micrometer screw gauge? We have 0.01 centimeter, 0.001 kilometers, 0.1 millimeters, 0.01 millimeters. Don't forget that both micrometer screw gauge and vernier calipers have their measurement graduated in millimeters. So the least measurement that we can have on the micrometer screw gauge, or the smallest reading, is 0.01 millimeters. So let's check. That's correct. With this, let's go for the summary available for the day, and let's pick the correct statement. Measurements that are both precise and accurate are not close to the exact value. That statement is false. Measurements that are both precise and accurate are close to the exact values. Accuracy does not have to do with the closeness of a measurement to its true value. That's false. Accuracy has to do with the closeness of the measurement to its true value. Now, precision is the closeness of two or more measurements to each other. That statement is perfectly correct. So let's check. As you can see, correct. The vernier caliper has two scales, the main scale and the vernier scale. Correct. Let's check the second and the third statement. The vernier caliper has the ratchet, sleeve, and tibble for taking measurement. That is in relationship with what? Micrometer screw gauge. The micrometer screw gauge has the fixed jaw, movable jaw, and the clamping screw. That is wrong. That is what the vernier caliper. So we stick to the fact that vernier caliper has two scales, rather, the main scale and the vernier scale. Let's pick. Yeah. With this, we've come to the end of today's class. Kindly do well to visit our website www.edubbey.com for more of our interactive books and video. Subscribe, subscribe, subscribe. We'll be waiting and to give you the best of our services. Thank you.